All right, good morning. Welcome to the session on Kotlin for Java programmers. I'm going to talk about some of the wonderful features we can use in Kotlin. But before I get started, let's talk about what is maybe special about Kotlin. Well, talking about ice creams, some of us like vanilla ice cream, some of us like chocolate ice cream, some of us like strawberry ice creams. I have a son who will take a chocolate ice cream and put chocolate on it. I kind of always wonder where your parents do this. But the point really is, we kind of like a different mixture of things. Personally, I'm a big fan of the Neapolitan ice creams, where you can actually have all of them together. Well, Kotlin is kind of like that. If you went shopping for really good, interesting features from different languages, and you said, oh, look, I like this in C#, I like this in JavaScript, I like this in Scala, I like this in, well, Python and Ruby, well, you start collecting all these features, you put together into a blender and then turn it on. What comes out of it is Kotlin. So Kotlin has actually learned from a lot of different interesting features from a lot of different languages, and they put it together. Well, Kotlin is a statically typed language. It compiles down to Java. It can also compile down to JavaScript. And one of the beautiful things that to say about Kotlin, some of them are that it is actually extremely fluent. Well, fluency is something nice because fluency helps us to write better code, use certain patterns in a better way as well. It's elegant. Like I said, it brings wonderful features from a lot of different languages. And that's what I want to focus on today, show some of the features of Kotlin so we can see what benefits it provides for us. Any questions or comments, just about any time is a good time. So don't hesitate, just fire away, and I'll be delighted to hear what you have to say. Let's start with some basics. How do I write code? How do I compile this code? How do I run it? There are several options to do this. So I want to start with a few different examples here just to see how we can do this. So I'm going to first of all start with a little main function. Let's say we have an argument right here. We'll call it as an array of string, let's say. And in this case, of course, we want to implement this main method. What do I want to do within the main method? I want to simply say print line, and we will say hello, if you will. And let's go ahead and say this is going to be arguments, which is given to us args, and square bracket 0. So that's a fairly simple code, as you can see, a main function with a hello world, a good place to start, a little hello world example. But how do I compile this code? If you want to write more, you can write in this absolutely. But here's how you can compile this code and you can run it. So all you're doing right now is running Kotlin C, which is the Kotlin compiler. And you're saying the name of the file, which is sample.kt, that's the extension. And include runtime pretty much bundles up the Kotlin jar for you. So when you run the program, you can just use Java to run it. You don't have to say anything else extra. And I want to put the destination into the sample.jar. That's what I want to put the stuff into. So that compiled the code right there. Now all I'm going to do is Java right here. I'm going to specify the jar file that I'm going to be interested in using, which is the sample.jar. And I'm going to specify what to run after all from this. In this case, I'm just going to use the class path to the jar file. And then the name of the file is called, the class is called sample.kt. That's a default name it's going to give for us. And obviously, in this case, I'll provide the world for it to run. And you can see the hello world being displayed right there. So that's one way to really compile the code and run it. Well, that's a little boring way. You can still do it that way. Or alternatively, what you can also do is get rid of the jar file at this point, but we can run Kotlin C and produce the classes in the classes file. And then once you do, you can run Kotlin itself. You can specify, in this case, class path to the classes directory. And then, of course, sample.kt, which is the class we want to execute, we can run that from there as well. Again, to run it, of course, you specify the class path, and I should specify the world to run the hello world at this point. So you can see the hello world being displayed right there. So, okay, that's great, but I'm a huge fan of REPL. Even Java now has REPL. Java 9 has JShell. Well, almost every useful language today has a REPL. I'm a huge fan of REPL because REPLs are a nice way to experiment and play with a few things in the code, and I want to really use a REPL. It turns out Kotlin C is already a REPL. So just run Kotlin C without any arguments, and now you're within the REPL for Kotlin, and 3 plus 5 right here is 8, for example, or I can go ahead and print out, let's say, hello there, and you can see that we are actually working with Kotlin right here within the REPL, so you can play with it. So this is a really nice way to try out a few little examples. You would use this REPL for all the purposes you would normally use REPL for if you're into using REPL for what you do. But my favorite part really is when I can run things as a script. This is one thing I really enjoy in languages is when a language gives me the flexibility to write full-blown classes or scale down to writing scripts when that's really adequate for my purposes. So we can use this as a script really well also. Let's see how we can actually do this. So to understand how this can work, I'm going to rename this as Kotlin KTS, sample.kts, and let's take a look at the KTS file right now. It's the same one we had a minute ago, but I'm removing a few things from it. So I stripped it down just to the print line at this point, and all I have is a print line hello, and then that particular line of code. But I want to execute this. How do I execute this little line of code? All I'm going to do for that is simply run Kotlin C, but this time I'm going to say script, and the script I'm going to run is the kotlin.kts. I provide the world next to it to execute that little script and run it as an hello world. And that's exactly what we're going to do here. Excuse me, is simply run this as a script because that's really easy to play with. So let's go ahead and get rid of this for a second. We will simply say hello there, and I'm going to simply start firing it up here in the editor, and that's hello there, executing as a script. So not much ceremony at all. Let's now talk about some language features and how we can actually use it. Let's talk about some nice things that are in Kotlin. The very first thing is, did you notice there are no semicolons? Isn't it amazing that you don't have to put semicolons? Your pinky begins to actually thank you. And there's a reason why the pinky is really short, isn't it, and lean. Now it's beginning to shine a little bit. It's like, okay, why me always putting that semicolon? Don't have to do that. But also notice, we didn't write a class. We didn't write a function. All the things are gone. You don't have to really write anything you don't want to care about. That's one thing. You also have sensible warnings in the language. After all, a compiled language, a statically typed language should give you a fairly good amount of feedback when things are not really looking good, and it can start giving you some of these feedback. For example, let's say we write a function called foo, and I take some input, I don't care what that is right now, and I call this function foo. In a programming talk, you need to have a foo somewhere. So right there, I took care of the checklist. But when I run this code, notice that I called foo, but I actually get a warning. It says parameter A is never used. Warnings like that can be very useful to know that maybe you're not really looking through the code. It gives you a feedback pretty quickly. Similarly, Kotlin is a statically typed language, but type inference is something we can really benefit from. If you're used to type inference in Scala, this is very similar to that. If you're used to type inference in Java 10, well, it is trying to provide you some similar capabilities as well, so you can really benefit from some of these. To understand this, let's take a little example and play with it. Let's start with a little variable. We'll call it as greet is equal to, let's say, hello, but I'm going to say this is a string that I'm going to provide right here. Then I'm going to just simply output the greet right here and print it out. Well, in this case, the greet is a string. Notice that in languages that we are used to normally, we put the type and then the variable name. Kotlin kind of emphasizes that, the variable name is more important than the type, so the type follows the variable name in the case of Kotlin. That's how they actually provide it. And of course, in this case, I'm going to take greet over here and change it to hi, and I'm going to print the value of greet, and as you would expect, the value hello changes to greet. However, if I take greet and assign a value of 1, you'll get a compilation error because you're not supposed to really assign a number to what is a string. Again, even though you're running it as a script, it is compiling, it's not partly running the code and failing, so that's a pretty darn good thing. Well, okay, this is great, but this is where we say what the type is. However, if you look at this code, it's kind of obvious what the type really is. The type is a string. Why bother saying what's really obvious? So as a result, you can remove that colon string, and when you execute the code, notice the code actually works still. Make no mistake, it clearly knows what the type of the string of the variable is, and if you're in doubt, simply ask the question, a Java class, and ask what the type of greet is. And the greet, of course, is pointing to an object of string, but it's holding on to a variable of type string too. But how do I prove that in this case? Well, very simple. Try to assign a value of 1 to it. You'll get the same compilation error that you got a few minutes ago because you're not allowed to assign a number to a type string. So the type is inferred at compile time. That's type inference right there. Having said that, you can go a step further with Kotlin. One of the things we are beginning to really realize as time goes on is we're doing more of functional programming code. If you're in my last talk, I emphasized why immutability is very important. So for that reason, Kotlin wants us to make a very clear choice when we write code. And so Kotlin gives us two different values, or two different ways to write it. You can say val, for example, let's say number 1 is equal to, let's say, 100. And I'm going to then print out number 1 right here, and that prints out number 1. However, it also gives you one more thing, which is var number 2 is equal to 100. You may wonder, what's the difference between val and var? Well, here's the difference. Var is actually called as the keyword of shame. So if you use it, you don't make eye contact with your colleagues that afternoon. You look down on the floor as you walk, and they say, you used var in your code, didn't you? You're like, I'm sorry, I'll refactor the code this afternoon. The point really is, it's really giving you the ability to mutate variables. That's why I call it as a keyword of shame. So in this case, you will notice that I'm going to print out number 2 as well. And you can see that both of the values are 100. However, if I try to modify number 1 to, let's say, a value of 7, I'll get an error at compile time because it's a val which is immutable. You cannot reassign to it, much like in Scala, for example. On the other hand, of course, if you're modifying the number 2 to a 7, you don't get any errors. So if you want safety, that you don't modify or mutate stuff, use val. If you intentionally want to create something that's mutable, of course, then put a bar towards it. This is not only in local variables, this carries through fields in the classes as well, as we will see a little later on. So we saw the val versus var. But that brings up to some really wonderful things like string templates. And this can be a really powerful way to write code. So let's go ahead and say for a minute over here, we want to create, let's say, a variable or a constant. In this case, we'll say name is equal to, we'll say Sam right here. Now that we have a name, we can output right here and say hello, but we can simply put a name right here without really much ceremony to print out, in this case, hello Sam. So a little expression with a dollar symbol gives a string which can be evaluated, and so we can put expressions into it. If you want to put a little bit more expressions in there, you can do that with the little curly braces as well, and then you can start putting expressions. For example, I want to know the length of that particular name, which is 3, of course, and then you can see that it's bringing that out. So you can start using the expressions in the code very easily by using the template literals. If you're used to the Groovy language, it's pretty much similar to what has been available in Groovy, so a lot of those features. I said something was like in Scala a few minutes ago, that's like in Groovy, so you can see features from multiple languages really come through and shines here in Kotlin. So that is an example of using a string template. On the other hand, we can also do a little bit of multi-line strings also. How many of us have written code where to create a multi-line string, use a plus equals, plus equals, plus equals? That becomes very tiring and error-prone and boring. Well, you don't have to do that. So what you can do here is you can say memo is equal to, and you can say this was created, and in this case by, and I'll make a mistake, but I'll correct it in a few minutes, name. But then I will go here and say, let's say on this date at whatever I want to create it. Then I want to just go ahead and print out the memo right here. Well, in this particular example, I said I'll make a mistake. Well, that didn't really work really well because I put a string. But what I can do is I put 3 strings right here, or 3 quotes right here, and turn that into a multi-line string. And as a result, now you can see it says this was created by, and then it says that. Now, when you typically write code, however, you want proper indentation in your code. You don't want to do different indentations for different parts of the code. It becomes nasty, hard to understand. So you would normally like to create an indentation like this. The problem, though, is notice that there's indentation in the output as well, which is not very pleasant. So what do you do about it? Well, one way you can remove that is by putting a little vertical bar. And then what you can do here is, notice when I output, it still has the vertical bar and the tab as well. But in this case, I'm going to say trim margin. And this understands the vertical bar as something that can be removed. So it'll look for everything until the vertical bar and strip it out. That becomes a nice way to indent your multi-line string and yet not have the indentation show up in your text. Well, obviously the question is, what if I don't want a vertical bar, a vertical line? What if I wanted something completely different? Well, choose your syntax, whatever you like to. In this case, I'm going to use a tilde, which is pretty arbitrary. Then I'm going to simply say this is going to be a tilde, and I can specify that really nicely here, and you can see that it doesn't show up anymore. So you can start customizing some of these things very easily as well in the language. One last thing I want to quickly mention is I'm a huge fan of languages that have expressions over statements. Why is that important? Just try this for a minute. Say the word statement. It's like life was taken out, isn't it? That feels so grim. Now say the word expression. I see people actually smiling already, right? It feels a little light. Well, a truly functional programming language has no statements at all. Everything is an expression. Well, why should we call it as an if statement? Why can't if be an expression? Well, sure enough, notice here, I say age is equal to 17. Now I say can vote is equal to, I'm going to say if age is greater than 17, I'm going to say please vote. Otherwise, else, we will say not so fast kid. So in this case, we have a if expression, as you can see, no return really, but if is going to return this part or the else part, depending on what we are doing. So to make sure this actually is working, let's go ahead and try this out. We'll print out the can vote, and you can see in this case the output tells us not so fast kid. So that's an example of an if expression rather than being a statement. When a language begins to have expressions, it becomes a lot easier to compose other operations with it. Another reason I really don't like statements is, if you really think about it, statements force mutability on you. Because when you call a statement, what does the statement say? You call me, I'll do some work. Well, thanks, statement. What did you do? I won't tell you. I put it over there, go get it for yourself. Expressions are really nice. They will do the work for you and return the result over to you. So expressions don't force mutability on you. Statements do. That's one of the reasons I really like expressions more than statements. And so you can have these kind of expressions and avoid mutability unnecessarily. Let's talk about functions. Well, Kotlin wants you to remember one thing. It is one thing to go to work, but it's one thing to really have fun. And they want you to have fun. That's why it's called fun. So every time you write code, you want to know that you're having fun. So fun over here, greet, and you're writing a function called greet. And then, of course, in this case, I take a name, we'll say string right here. And then what am I going to say? I'm going to simply say hello, $name, and return it. Well, that's a simple way to write a function. The equal simply says this function is returning a value. In this case, we are using what's called the type inference. The return type of the function is actually inferred at this point. So as a result, if I were to say, in this case, result : string is equal to greet, and let's say in this case, Kim, and when I compile this code, over here, let's say OK, notice that we don't have any errors. It said OK. On the other hand, if I said int over here, it gives us an error because we have a mismatch. The function is returning a string you cannot assign to an integer. The type inference took place already for you. Of course, I want to really print out the result of this call, so we'll print the result, which is hello, Kim, of course, at this point, and you can see that it's printing that right there. So the point really is the type is being inferred in this case, and that works really well. But you're not required to use type inference all the time. What you can also do is you can specify the type explicitly if you wanted to. So in this example, as you can see, we have said return and then hello name. And now we are saying explicitly that the return type of the function is a string. And of course, when I execute the code, you can see that the code produces the same result. A little bit more work. But if you really want to specify the return type, you can. Question is, when do you do and when you don't? Generally speaking, I would say when you write an external-facing library, always specify the type. Don't leave it for people to guess. But if it's an internal piece of code, let's avoid the ceremony. It's kind of like how you normally dress up, right? Being casual at home versus going out, it's the same kind of idea. You don't have to be too formal within your internal library code, but be a little bit more formal when you're outside. Exactly the way to think about it. Well, not only can we specify that, we can also write void methods. They are called unit as against void. And to do that, all you have to do is simply don't put any return type over here. That becomes a void method by default. You're not returning anything at this point. So for example, in this case, I'll just go ahead and print out right here the value that I'm going to print out. And in this case, of course, I'm going to simply call greet and pass to this, let's say, Joe. And you can see when I run the code, it's going to simply print Joe. But what if I try to print the result of print Joe at this point? Well, that's a void method. So you got a Kotlin.unit, which is the return type. There's nothing really useful out of it. So that's basically, again, remember, everything is an expression. So that's one of the reasons why it's a unit and you can work with it. Well, that's good so far, but here comes a charming feature. We can actually use default arguments. If you have kept up with what's happening in JavaScript, some of these features are available in JavaScript as well, in ES6 and so on. So this is one of the reasons I like learning languages, because when I start learning a different language, it usually is like, oh, I've seen that before, I've seen that before. So that becomes really easy to adapt to languages as well. Let's look at an example real quick. I can go back to this greet method. This time around, I'm going to call this with Jerry right here. But I want to specify comma message is going to be a string. And in this case, I'm going to change this to a message, if you will. And so I'm going to specify Jerry and hello. And I'm going to pass that, the two values to this and ask it to print out the greeting message for Jerry. So you can see it says hello, Jerry, right there. But I can also go a step further and I can call the greet method and pass Jerry. But notice, I'm not going to pass the message. I want that to default to the value of hi, as you can see. So this time around, it says hi, Jerry. But even better, one of the nice features is when you are using the default parameters can actually depend on previous parameters as well. So in this case, I'm going to say name.length, if you will, and this is how you can say a high five to Jerry if you wanted to. So that's another example of how you can actually use the default parameters to depend on ones previously available as well. That becomes a nice way to reuse some of the data while you're encouraging people to use default arguments, if you will. So that becomes a very powerful way. Like I said, a lot of these things are available in JavaScript these days. So these concepts are kind of becoming prevalent across languages, which is really nice. Similarly, you can actually take this to the next level, which is pretty brilliant in my opinion, because you can also use what are called named arguments. That gives you really good flexibility. Let's look at an example of this. I can come down here and I can say name is going to be equal to Jerry, and I can specify a value, a named argument, if you will. And notice I can say comma message is equal to, and I can specify, let's say, howdy. So I can specify named arguments, and that can become a lot easier to work with. You're not required to follow this ordering, if you will. Notice that I'm going to say message is equal to howdy, and the name is equal to Jerry. I can switch the ordering as well if I wanted to. Not only can you do this, you can specify the name as a positional argument, comma message is equal to howdy as well. As you can see, you can mix and match them really nicely. So that gives you quite a wealth of flexibility. So in other words, you can turn the dial any way you wanted to. Where you think the code will be more expressive when you say the name, you can. Where you think it's obvious, you can kind of dial it back to this way. It gives you the flexibility as a programmer rather than the language telling you this is the only way to do things. That's really flexible right there, as we can see. Not only that, we can do something else also. Let's say we can write a function called max, but I want the function to take variable number of arguments. So var arg is going to be numbers, which is of type integer, a collection of values. But what am I going to do within this method? I'm going to say numbers.reduce. And in the reduce method, I'm going to take a max value and an element, and I'm going to return using a lambda expression right here. I'm going to say if max is greater than element, then return the max value, otherwise return the element itself. So that becomes a really nice way to write a function which can take variable number of arguments in your code. This is else, of course. So we have a function that takes variable number of arguments right here in front of us. Now what I can do here is I can call the function max, but I can pass one, let's say 3 and let's say 2, and of course you expect the result to be a 3 in this case, and that actually worked. Similarly, we can also call max with, let's say, 1, let's say a 7, 9, and 2, and you can see that the result is what you expect. But where it really becomes exciting is, what if I already have values on my hand, which is an int array of, let's say, the values 6 and 8 and 12 and let's say a 3. Well, I want to know what the maximum among these values are. So what I can do here is I can say max of, but in this case I can do a spread operator on the values. Obviously, I cannot send values directly. If you notice, if I only send values right here, I get a compilation error because I'm not allowed to send an array when I'm expecting a discrete number of values, but I put a little star towards it. But again, if you're familiar with JavaScript, you will notice there are certain things you can do really well. For example, I can take some arbitrary values, 17, comma, let's say 2, and notice that I can put values in front of it and use the spread as well. Or I can also say 23, comma, 7, and you can see that I can put values before and after towards it as well. So you can actually start putting things together very easily using the spread operator. The language kind of speaks to you, or you can just fluently start writing code, and it's pretty flexible, as you can see. That becomes really fun to work with. Moving a little forward, let's talk about looping, because we do this very commonly and see how we can use some of these operations. So I'm going to say for x in, let's say 1 to 10. If you've done Ruby programming, this looks a lot similar to what you're used to. So I'm going to print the value of x, as you can see, and it includes the value of 10, as you see in the output. If you don't want to include the last value, you simply say until, and you can see that it does not include the last value. Oh, but I don't want to print all the values. I want to step through every other value. You can do a step 2 as well, and as you can see that you are skipping the values. But I don't want to really go from 1 to 10. I would rather go from 10 and then down to 1 maybe. You can do that as well if you want to go from 10 to 1. As you can see in this case, that is 10 all the way down to 1. And you say, but I want to really skip values as well. You can do that too by using a step on it. So it gives you, again, a lot of different flexibilities to start writing code in terms of iteration that becomes a lot easier to work with. And of course, you can also use a list of items also. So for example, if I wanted to say names is equal to list of, let's say Tom and Jerry over here, and let's say in this case we also include Spike. Now what I want to do is to say for, let's say name in names. This is what Java 5 really wanted to do, isn't it? Like a for loop with the in, we had to use a colon because in could be a keyword that people are using. Well, that's the benefit of creating a new language. There's nobody before you to use those keywords. So in this case, of course, I'm going to print out the name at this point, and you can see that the name is actually being printed. But what if I really want the index and not the names? Well, you can then say index right here, and you can go to the names and ask for the indices. And once you get that value, you can then print the index value right there fairly easily, as you can see right here. And that gives you an idea about how to get the index value out of this. But of course, as you know, you can also extract the value as well. For instance, I could say something like names.get and provide the index, and I can do that also. So it gives you a fairly good amount of flexibility for you to work with things. So the plain vanilla for looping with a lot of different added benefits, as you can see, becomes really powerful way to execute these things. And that's basically what we saw just now, how we can use some of these little features. To me, one of my favorite things really is I would write code and maybe spend the next 20 minutes trying to figure out how to make the code really expressive. I care about that a lot because it's me, maybe 2 weeks from now or 2 months from now trying to understand the code. And if I can avoid some of the duplication of the code, that's really nice. And this is where pattern matching is something I really like a lot. You're going to see features like this in Java, future versions of Java, which is nice because once you're comfortable with some of these in other languages like Kotlin, it becomes easy to adapt to languages when they evolve as well. So let's talk about the when. Like I said, when is something I really like a lot because it is amazingly fluent. So to understand this, let's take a look at a couple of different examples. Let's call a process right here, and we'll pass a 1. but let's also pass a few other things also. Let's say process 1, process 7, process 8, let's provide a 14, let's send a hello right here, and then let's also send something as bizarre as simply a string builder. Okay, so what am I going to do with all of this? Let's start writing a function called process. So the fun process is going to take an input, but because I'm sending so many different things, that becomes a type of any. Within that function, what am I going to do? Let's start by simply printing the input, just for an example, without much effort at all. That just printed all of that, no big deal, but any is the type I gave here. But what I really want to do is I want to say when input, and here comes the charm, I'm going to say else, and the else simply says print out I have no clue. Just like what I normally do, I have no clue what I'm doing, and it's just, that's all it's going to print, I have no clue. However, it gives a warning because I've not used the input. Well, great, we can now do something with the input. So what am I going to do? I say the value is 1, and I'm going to simply print out 1 right here. So in this case, you can see that it printed 1 because the value was 1 on the first time, and everything else is different. But here comes the beauty. I can say 7, 8. Isn't that beautiful? I can say 7 or 8. And now, of course, for the 7 and 8, it says 7 or 8. So you can actually provide a discrete set of values and say, if you match one of these, go ahead and use that. Well, not only can you do this, you can also say, well, what if I am in 13 to 19? Well, then I'm going to say lazy as a teen. So in this case, when I run the code, you can see it says lazy as a teen. So as a result, you can actually have a range of values that you can look into also. But not only can you do that, you can say is string, and then what am I going to do here? Print line, we have a string. So when I execute this code, if the type is a string, we have a string. But wait a minute though, I want to say what the size of the string is. Before we go further with that, let's switch over really quickly to languages like C++, Java, and at least the current state of these languages. Let's talk about how we would do something like this. You would do something like, for example, input instance of, using the Java syntax, you would say string, and then what are you going to do? You will say output, for example, and how do you output the size of the string? Well, if you try to do input.length, you will get an error, isn't it? What do you have to really do? You have to take this code and you have to wrap this around like this, and then you have to say, this is string, and then you would have to do this, right? Does anyone remember what this is called? No, it's called punishment, right? That's what it is called, because you have to pay the taxes, isn't it? So why have to do this? Why can the language really know this? Here's the good news. Java is going to do this when pattern matching becomes available, because languages are beginning to realize, you know what? You don't work for the compiler should work for you. Whereas in this case, you are putting all the effort to the compiler, but why? There's no reason to do it. Well, here's the charm. What you can do here is we have a string of length, and then I'm going to put a dollar right there and say input.length. No, make no mistake, you cannot call input.length outside of this branch. This is only valid within this branch, because only within the branch the string, the input is a string type. Outside of it, it's any type, and you don't know what the type is. So as you can see in this example, we have a string of length 5, and you can see that actually do the job for you. So a very sensible way of doing things. You probably have seen something like this in Groovy already with compile static. Well, that's exactly what Kotlin does pretty nicely here as well. So the auto casting is something really nice for you to use. As you can see in this particular example, very nicely comes together for you to apply. So that's why I said this is one of my favorite features. Is a lot of good things that come through in this particular example, as you can see, that you can benefit from. So that's basically a use of the pattern matching. Let's talk about a few other things. There is a null type also, which is pretty darn good. To quickly understand a null type, let's call a greet method. And if I say, let's actually call this as, let's say, nickname, and I pass a name here as a string, and what do I want to return? A string from here. But I'm going to say if the name is equal to, this is a poor implementation, let's say Robert, then I want to return, let's say, Bob. On the other hand, what if the name is not Robert? Well, I want to return, let's say, return null. Well, I know null is not very good, but let's try this. So what am I going to do now? I'm going to go ahead and print out nickname and pass Robert in here, but I'm also going to call nickname and pass Venkat over here. Notice I get a compilation error. And the reason I'm getting an error is I cannot return from any place I want to return because string is not nullable. So how do I really tell that it's okay to return null from this code? You put a question mark. The reason they used question is they want the programmer to think about their own sanity. And the point really is here is that, do we really want to really return a null? That's what you're doing. This example is dangerous for a couple of reasons. One, that people will start using this to return null, but even worse, they think that Venkat's nickname is null, which is not true at all. But the point really is that you are able to define nullable types in this case, and that's what in the return type you can say string question to say it's a nullable type of string, then null is actually allowed. Let's reverse this. What's going to happen when I receive a name which is going to be nullable? So to understand this, let's write a receive method. And in the receive method, I'm going to receive a null. So let's go ahead and remove this for a second. So I'm going to call the receive and pass, let's say, Joe right here. But I'm going to call receive and pass a null to it. So in this example, notice that I got a warning, but it didn't error out because I can pass a null to this code. But how do I really get the value out of this? One way to do that is to, well, what if I tried to say the following? What if I said name.length? Well, notice I get a compilation error right now because length is not a method of the nullable type. I cannot use length on name because name could be null, and that would be really unsafe. So the language is protecting us at compile time. So what am I going to do? If name is not equal to null, then I can say over here, output will say length is, and we will put a $name.length, and you can see how sensibly it's able to work at this point. Otherwise, I say else, and we will simply say over here, length is going to be 0. Let's say over here, length is 0. So when I execute this code, I was able to use name.length on line 3, but I cannot use it outside of the if part because that's not guaranteed to be null. I know while this code works, it's a little verbose, not very pleasant. We can actually minimize a lot of work here by using some really beautiful, sensible operators. So notice what I'll do here. I'll say length is, and then a name.length with the question in front of it. This is going to return either the length or it's going to return a null if the length does not exist. So you can see in this case, so in this case you can see that I'm able to get the value of the name, and if the name were not present, let's make sure I call this correctly. So when I call this, it's going to return the value for us. Don't know what happened over there. What did I do? Oh, a code. That would be really useful to have. Thank you. So let's go ahead and run that right there. So you can see it says 3 versus null. But I don't want really a null. I want the value 0. Not a problem. A question colon and then a 0. And you can see beautifully you're saying, if the value exists, give me that value. If the value doesn't exist, then give me the value 0 at this point. So it becomes really concise. Rather than having to write the code in the top, you can simply write code like this as well. I know it takes a little bit of getting used to the syntax, but once you do, it becomes really concise, as you can see. Very, very nice. You can also write functional style code as well. You saw me use reduce a few minutes ago. Like that, you can use filter, you can use map, you can use all the functional style code you are used to. I showed you an example of lambdas before, so you can continue with that further and use pretty nice functional style code as well. I won't go into the detail right now. But let's talk about extension methods real quick. This is a very interesting feature in my opinion, but we got to use it a bit carefully. So notice what I'm going to do here. I'm going to say in here, hello.shout. And I know we don't have a shout method, right? So it failed saying, I don't have a clue what you're talking about, there's no shout method. But who says I shouldn't have a shout method? I want a shout method. So fun string.shout, and I'm going to put this to uppercase right here. And notice at this point, you can implement the shout method. Now, keep in mind, this method you're adding is not actually part of the class. It's the compiler that is actually doing the gimmick for you. The compiler says, oh, look, you're calling this method. Before I complain, let me look in the extension. If it is there, I'll rewrite this code to call that. Well, this is really nice. A few weeks ago, I was giving this talk, and a developer got extremely excited and said, hey, can you do this, he said. And what he wanted me to do was to change to lowercase to uppercase. And I said, why not? We live in a free country. It's your code. You can do whatever you want to do. He was extremely satisfied, but I was very concerned at his satisfaction. But the point really is, you can definitely do that as well if you really wanted to shoot yourself in the foot, but the goal is not to do. This is where I really have faith in code review. Like, please, somebody look at this developer before he goes away. And so, now, don't take a photo of that. So you don't want to do that, so absolutely. Well, just because it's possible doesn't mean you want to do it. Well, class is absolutely phenomenal the way they have done this here. So let's create a class called car real quick. What I want to do in the class car is to say year of registration. So year of registration here is going to be registration is going to be equal to 2010 for a minute. Then I say car equal to car, just like a constructor. You don't use a new in this case. I'm going to just print out a car dot year of registration and print it. That's a var, as you can see. It's a variable I have created. So I can say car dot year of registration is 20, let's say 17, and I'm going to then print a car dot year of registration, and you can see it changed to a value 2017. But of course, I'm going to say car dot year of registration is going to be 2020, and I'm like, no, you can't do it because you can register in the future. Okay, how do I really say you cannot register in the future? If you're programmed in C#, you know where I'm going with this. Set value, much like you do in C#, and then you can say if value is greater than 2018, throw runtime exception, and then I'm going to say sorry, not in the future, or whatever that you want to display. Then you say field is equal to value. So this allows you to set the field value if there was no exception, and you can see that it actually blows up saying sorry, not in the future. But of course, if I don't try to set that value, you can see that it's able to set the value to the value you want to. But of course, if you really want to make it a private setter, you can throw the word private right there, and as a result, you can see that you're not allowed to modify this anymore. Line number 12 gave you an error because it's a private property. So you're defining these as properties rather than variables or fields. The name of the field is hidden from you. This is actually a property that you're really dealing with at this point. Well, that's great so far. But you can also define, in this case, some really cool things about other properties as well. So for example, I'm going to say car dot, let's say, years since registration. And years since registration is a property I'm going to create right here. So I say val years since registration get. And this is going to simply say 2018 minus year of registration, and that tells you how many years have gone by since the time of registration. This is years since registration, as you would expect. And so as a result, when I run this code, you can see that it tells us there are 8 years since registration. So that's a way for you to create a getter property without a setter as well. So that becomes really nice to create. I'll show you a few different variations of this in just a few minutes as well. So I talked about the backing fields. I talked about the private setters. What about static methods? Well, if you're programmed in Scala, you don't have any much learning to do at this point because it's very similar to Scala, maybe except for a bit of a syntactical difference. So let's talk about that real quick right here. So I'm going to say object util, and in this case, I'm going to create a function get number of, let's say, processors, or cores rather, get number of cores. So get number of cores simply says equal to, and I'm going to simply return runtime.get runtime, and then this is going to be, of course, the available, available processors, and so that becomes a little static function we created, a class with only static methods in it. So to output, I say util.get number of cores, and you can see that it gives me the number of cores on my machine, which is 8. Similarly, I can define a class called a car right here, but within the car class, I can create a drive function, and in this case, I'm going to simply say driving, and as you would expect, I can create a car object, so we can say car equal to car, and at this point, I'm going to simply say car.drive to call the drive method. Hey, but what about static method though? Well, what I can do here then is I can say companion, and this companion object is going to be having a method, let's say, kind, and I'm going to simply return, let's say, electric from here. Then as a result, I can come here and simply say car.kind and call the kind method. Notice the case difference. I'm calling this on the class, not on the object. A lowercase car gives me an error. Uppercase car is just fine because it's a static method. So you do with companion objects. Again, if you're used to Scala, you pretty much following the same thing with a little bit of a difference in syntax. You're doing very similar things in here as well. Well, given that, of course, you can also have data classes. Data classes are classes which are supposed to be just immutable stuff, not much behavior in it. Java is going to have data classes in the future as well. Well, you can kind of get exposed to it really quickly. Before we go further, let's quickly talk about inheritance, and then we will move on to the next concept, which is pretty exciting. So class, let's say person, but my class contains a first, which is a string. Did you notice I put a val? I don't want you to mutate it, but I've created a property within the class called a first. Similarly, I create a last, which is a property as well over here. Now that I created a class right here, we'll say override, and override fun, in this case, to string. And all I'm going to do is return from here, let's say the first and the last. So that's a person class. So I could say, for example, Peter is equal to new person, and this is going to be Peter, comma, let's say Parker. And once I create this, of course, I'm going to print out Peter right here, and you can see from the output you have the Peter Parker being printed. On the other hand, what I can also do is create a class, and this is going to be called as cool person. And this cool person takes on a first, which is a string. Notice I didn't put a val, and I put a last, which is a string as well. But I'm going to use inheritance to person. Hey, where did that colon come from? Well, Kotlin really wants to make everybody happy. C# programmers are so happy right now. So you can simply say first and last right here. This code will not work, not because we use the C# syntax, but the problem here is that the classes are not open automatically. You get an error. What's the problem? You cannot inherit from the person class unless you open it. Now that I've opened the class, I can inherit from it. I'm not getting an error anymore. So now I can go back to this code. And what I can do here is I can say var, let's call this as coolness index. And this is going to be a value of 5, let's say. Then I can write a constructor. We'll come to the constructor in just a minute. Let's override the toString method. But in this case, what I'm going to do is simply say super.toString and then print the coolness index right after that. Oops. So I'm going to print the coolness index right after that. Let's talk about the constructor. The constructor takes the first and the last, so I'll just copy from here. Again, if you're used to Scala, this is very much like you use in Scala. So index, of course, int, and you simply say this, and you pass the first and second. And the reason for this really is that the idea is that this is a constructor that you're writing rather than a class. And as a result, that really sends the data back to the constructor. And then, of course, coolness index is equal to, let's say, in this case, the index. So we wrote a class called the cool person. Let's define Alan is equal to cool person. Let's go ahead and say Alan right here. And of course, we will say the coolness index is all the way to the top. And of course, when I print Alan right here, we want that to be printed with the name and of course the coolness index. That's a way to inherit from the code as well. So we can use inheritance. Again, you have to open a class before you can inherit. So what I'm going to do is to show you some really amazing features in the next few minutes. If it's okay with you, I'll run over by 3 more minutes. Is that okay with you? All right, let's do that. So I want to show you a couple of interesting features you can actually use here. Let's quickly look at a compute method. And the compute method is going to take a value, let's say int. And what I'm going to do here in this is I'm going to simply say, oh, let's go ahead and print out, let's say called right here. And then I'm going to simply say, return the value of n. Well, then I'm going to say x is equal to 4. If x is greater than 5 and the compute of x is greater than 7, we'll simply print out, let's say, path 1. Otherwise, we'll say else we'll print out, let's say, path 2. Well, when I run this code, of course, you're going to get the output for the path we are going to use in this code. However, if you notice over here, the compute method is not called because of short-circuiting. Let's see where I made a mistake here. Does anyone see the error? So I have a path 1 and path 2 in the else. The compute method, print line, I can't see the error. Let's try this one more time. So no, it's angry. Okay, let me just move on a little bit further. What I want to show you really here is, what if I really move this to a temp, and then I were to say val temp is equal to, and set the value. Well, the problem in this code is it will evaluate the compute method. One way you can avoid it is by deferring execution. You can say by, and you can then postpone evaluation, and this becomes a by lazy, and that would be the syntax for it. So you can say val temp by lazy, and that way it'll postpone evaluating the temp until it really is required and avoid otherwise. Well, what I want to show you next is two interesting features, which is an infix operation, and I'll create a DSL in the next about 3 or so minutes. So let's create the first thing, class pizza. You cannot have a talk without pizza, right? So here we go. So what am I going to do? Pizza is equal to pizza. So I created a pizza. Then I say pizza.spread, and I'm going to spread some sauce on the pizza. So sauce. And then I'm going to say pizza.spread, and I'm going to spread, in this case, cheese. Okay, so how do I write this? I'm going to define a function called spread. It takes a certain item, which is a string, and all I'm going to do simply is print out right here, let's say spread, let's say item. Okay, so a simple example, sure enough, that code actually works. But wouldn't it be really nice to do the following? Not having to really specify the dots, not having to really specify the parenthesis, isn't that cool? Well, yeah, but it doesn't work. So how do I really make that little piece to work? And for that, you go here and say infix, and you make that work with the infix notation, and that works. This leads to really ability for us to create some beautiful DSLs. And I'm going to show you in the next few minutes, evolve the code to create a really fluent syntax by applying some pretty nice features in Kotlin. So what I'm going to do here is to create a class called, let's say, robot. And my class robot is going to have a function, let's say fun over here. We'll call it as turns, and direction is a string. And all I'm going to do is print out turns, let's say the direction that we want to display. Similarly, we'll write one more. This is going to be called as runs, and this is going to be speed. And this is going to simply say runs fast or whatever that I want to run it. Okay, great so far. How do I use this? Let's start with baby steps. Robot is equal to a new robot. And once I create a robot, what am I going to do? Robot.turns, and let's say left. And then I'm going to say robot.turns, let's say right. And then, of course, I'm going to say robot.runs, and we will say fast. Okay, this is very trivial, traditional example of creating things for us. Nothing really exciting at this point. But on the other hand, what I really want to do here is to make it a little bit fluent. So to make it fluent, what am I going to do? I'm going to make this as infix right here. And as a result, we can remove this part right here. I can remove this parenthesis. And then, of course, I can remove this ending parenthesis also, but something tells me you're not going to be happy with it, because you're like, come on, that's like exactly the same example as before. I want something more. Okay, fine. Let's do one more thing. Let's now go ahead and create a function called operate. And the operate function takes a function as an argument. This function says the robot, which is an object of type robot, it returns nothing, a unit. And within the function, I create the robot right here internally. And then I'm going to pass this robot to the function we have on our hand, and I will pass it to it. Now notice what I'm going to do here. I'm going to say operate and a curly, and I'm going to move this up to here. And within here, I'm going to simply say it. So as a result, operate, and you can say it runs, it turns, it, and so on. You're like, okay, that's great, but that string is a little ugly. Can we get rid of it? Why not? So notice what I'll do now. Val left is equal to left. And then I'm going to say val right is equal to right. And then val, let's say, fast is equal to fast. So very last step here. Now that I defined those strings, I'm going to remove these things. I'm going to say left here, right here, and fast here. Well, unfortunately, that doesn't work. So if I try to run the code, it doesn't work. But notice very carefully what the error says. Unresolved reference left. Now, this is where you need to pull in your JavaScript skills. In JavaScript, you can do a call method, and you can send a context object. Kotlin has the same feature. So notice what I'm going to do now. I'm going to go back to this code and say robot dot. This says I want this function to have a context object of type robot. It could be anything. In this case, it's just robot, but call it direction if you wanted to. Then I'm going to pass robot as a first and the second argument right here. You say, OK, that's great. The first argument is the robot, this object. Second is the argument you pass in. Well, if that is the case, why not simply do it this way? And Kotlin says, sure, why not? And you can do that as well. And you can see how it was not really hard to create that syntax, which is pretty fluid. Thank you for your time.